Hey everyone, in today's video we're going to have a look at timbers for the exam prep for A-level product design. So typically this will appear on your paper one. So paper one, which is the 2.5 hour long paper, is the one where it's essentially its materials, properties, manufacturing methods. So why has this piece of furniture been made out of this material? Why is it appropriate? How could it be manufactured? And those sorts of things. So what you need to actually know in terms of the timbers theory is what hardwoods are, what softwoods are, what manufactured boards are, be able to know examples of each of those, and then how timber is actually converted into like usable um, pieces of material. So these first couple of slides are similar to the ones that are on the metals and the polymers theory as well. So essentially, the main reason why some timbers are used over others is it comes down to properties. Now, basically you need the right properties for the right job. So if something's going to go outside, you need to make sure it's got a better moisture resistance than something's going to go inside. And if something's going to be hardware, it's going to be like take a lot of beating, so it's going to be used a lot and it's going to withstand a lot of general wear and tear. You need to make sure that it's a harder material as opposed to something that if it's just a display doesn't necessarily matter as much. So it's making sure you understand why each material has been chosen and why, and that's also why you can't just say it's made out of wood, it's made out of plastic, it's made out of paper or whatever it may be, because that's too generic and there are properties that distinguish between different groups of materials. So there are the two different groups, you've got mechanical and you've got physical. So mechanical is external forces on something, and then the physical properties are like internal of how the material actually physically works. So with mechanical properties, as I said, we've been through these before, but things like compressive strength, so being able to like withstand someone sitting on something, so your chair legs that you're sat on, obviously the material needs to have good compressive strength because you've sat on it. Tensile strength, being able to pull it apart, that's typically for things like moving parts, like caps in the engines and all these sorts of things. Bending strength, so how well it can actually bend without breaking. Shear strength, so sliding past each other like a pair of scissors. Torsional strength, which is twisting. Then you got hardness, which is resisting. Now it says abrasive wear on the screen, but it's also resistance to indentation as well. So the test for that is the um, dot punch test, which does the indentation, or you just put some glass paper or file across it and see how much damage you do in terms of the abrasive wear. Toughness is the sudden impact. Plasticity is how well does it keep its shape. Once you've deformed it, how well does it keep that new shape? Ductility is how much can you bend it without cracking. Malleability is how much can you deform it under compression. So ductility and malleability are often mixed up. The test is the same. It's where you put the pipe in a vise, bend it into the cracker bits on the inside or the outside, depends if it's ductile or malleable. Then elasticity, which is how much can you deform it and then let go and it snaps back to its position again. Some of these don't apply to timber, so obviously things like elasticity, you don't really get that. Now you do, okay, you've got things like FlexiPly and Flexi MDF, but you're not using them for their elastic uses. You tend to use them so you can form bits of furniture and that sort of thing. So those are external forces that you're putting on a material and how it will react to those forces. Physical properties are to do with the actual internals of things. So things like how well does electricity like flow through it. If it flows through very well, then it's a conductor. If it doesn't flow very well, then it's an insulator. Now the same will be done for electricity, heat, so thermal. You've got light, so opaque, translucent, and transparent. So opaque being that no light gets through at all. Translucent means it comes through a little bit and then it kind of diffuses the light a bit, so you can see through light, but you can't see an image. Then transparent being that it lights through really easily. Density, just how dense, how well, the mass of the material. Fusibility is the ability to convert it from solid to liquid, which doesn't affect um, timbers, along with magnetism. Again, self-explanatory, but that's only iron and steel for the metals, but it's important to have it on there as a property. Then corrosion, degradation, resistance. So that could be to do with moisture. So how badly will it degrade when it's outside? It could be susceptible to rot. It could be fungal attack, insect attack, anything like that. So that bit is to do with like, the properties of it. So we're going to look at some specific examples now. So we'll stick with hardwoods first. So these come from deciduous trees, so the ones which lose their leaves in the autumn. Typically they're slow growing. They can be like anything with like 100, 200 years, that sort of thing. They're a lot more expensive because it takes so long to grow. And it is quite difficult to preserve the resources because you can't just cut them down and grow them and suddenly you've got them again in a week or 2 weeks or a year or however long. Because it takes so long, it's just very, very difficult to maintain those resources. Examples that we grow in this country are typically oak, ash, and beech, and then we do import a lot overseas, so things like teak and mahogany. Now, the main examples that the example give are these ones: so birch, ash, oak, beech, mahogany, and teak. Like with the other materials, I don't suggest you try and learn every single one because it's not realistic, honestly. What I do is try and pick three of the most common ones. Now, the ones I would go with really, oak is the one everyone knows because you get all the adverts like oak furniture land, and most people hardwoods. If you ask someone to guess, they'd probably say oak. So I would make sure you know oak. Then I would probably go with something like teak because it's perfect for like outdoor furniture, and then you got beech, and that's typically used because it's so good for things like workshop benches in a workshop, tools because it's so tough, and then you can like steam bend furniture and that sort of thing. But we'll go through all six. But in terms of when it's ready for an exam, if you don't know, I would always either throw an oak, beech, or a teak out there. So we'll start with birch. So birch is very hard, so it's resistant to warping, so it would survive quite well. Um, when it gets a bit humid inside or wherever it is. Typically used quite a lot for furniture and also for veneering, MDF or plywood. So what you'll do is veneering is when you cut like a very thin layer of the material and then stick that on top of, um, as I say, plywood or MDF. And so you actually get things that's called like birch face ply, which has got quite a nice look to it. Ash, which is very tough, very attractive. It's a little bit flexible due to its open grain, and because of that flexibility, typically it's used in things like sports goods. Um, Not so much anymore with things like tennis rackets and squash rackets where they used to be made out of wood, but now they're more like carbon fiber and that sort of thing. But they still have a bit of bow in them. Whereas if you still need to have like a wooden piece of equipment that's got a bit of bow or flex in it, it's used quite a lot for that. So oak, which is one of the ones I would recommend you remember. It's hard, it's tough. It's got a very attractive grain, which is why it's used a lot in furniture. It does contain a tannic acid, which will corrode steel screws over time. So it's something you need to consider when you're working with it. Used quite a lot in furniture, bits of flooring as well, and then joinery, so in construction. Beech, which is tough and close grain. Now, with the grain, the closer it is or the tighter it is, typically the more dense it is and the harder wearing it is, which is why it's perfect for tools, tool handles, chairs, as I said, workbenches in workshops. And it's also really good when you steam bend it. So if you steam bend like in a steam chest, you put the material in, and it's got a closed grain, it will keep its shape a lot better than something that's got uh, a wider grain. So bear that in mind. Mahogany. Now, mahogany is the other one that people tend to know oak and mahogany quite a lot. Mahogany typically is actually quite difficult to work with because the grain interlocks. It's very, very dense. It's still used and it looks very nice. It's got a very, very nice dark reddy sort of colour. It's used for some beautiful pieces of furniture and cabinets and that sort of thing. But yeah, it's very difficult to work with because it's so dense. So typically, if you're going to use like a file or a chisel, it's going to be very, very unforgiving. And then teak, which is the one I said, if you're not sure an exam, go with, because it's perfect for anything. It's going to be hardwoods or something used outside. Now, the reason it's so good outside is because it has natural oils in it that resist moisture and acidic and alkaline things, which again is why it's perfect for outside. Because obviously, you would still add a finish to it anyway, oil stain, varnish, whatever, but it'll do a better job of surviving outside than any of the other ones. So that's hardwood. Softwoods. So opposite of these, so you've got evergreen, so they don't lose their leaves in autumn. They're relatively quick growing because obviously I say relatively quick because it's not like you can just plant a seed and a tree appears a week later. But you can get 5 to 10 years, maybe a little bit longer. Relatively cheap compared to hardwoods. Now, most like 90% of ours come from other countries like Norway, Sweden, Scandinavian countries. We don't have the climate for it. We do grow some in this country, so like larch, spruce, and Scots pine, but most of our stuff does come Scandinavia and places like that. So same sort of thing. We've got 5 examples. I'm not expecting you to remember all for the exam, but there are some very, very commonly used ones. So the most commonly used ones really are things like pine and larch. Really, those are the ones that you'd go with. So we'll go through them all anyway, just so you know. So cedar, so straight grain, low density, so it's very, very good at dampening sound. So it's used a lot in like cladding and soundproofing. Larch is hard to very good moisture resistance and looks quite nice, nice sort of colour. This is used for garden furniture. So if um, you're in a question where it's asking about garden furniture, you could say larch or you could say teak. The reason why you would pick larch over teak really is because of cost. Because teak is a hardwood, it's more expensive. So if you can't afford teak, you'd go with larch. But if it's say if price of cost was no issue, um, you would typically go for teak because again they're both good outside. Spruce, um, resistant to splitting very well. Typically just used for indoor furniture. Pine, so that's straight grain, very, very knotty, which is where all the branches come off. Used a lot in construction work, joinery, and those sorts of things. And if you ever made like a jewellery box in secondary school and they gave you a piece of softwood, odds are it's pine. It's very, very, very commonly used. And then Douglas fir, which is actually our Christmas trees. So very few knots in it, very good corrosion resistance, and it's used quite a lot in veneering, joinery, and construction. So the main ones I would think to remember on are really pine and larch are the ones I would sort of go with, really. So in terms of the actual cell structure of it, basically the thickness of the wall. So you've got hardwood, you've got softwood. So if you can see my mouse, the thickness of the cell wall here basically determines how dense the material is. So with hardwoods, because the grey area is a lot thicker, hence the material is a lot denser and it takes a lot longer to grow. So basically the water is coming up through these little white fibrous bits that you can see, and that's why it takes so long. If you imagine it's almost like trying to drink a drink with a really, really fat straw, it's going to take a lot more effort to actually get that liquid up. Whereas with softwoods, much more narrow cells, water comes up a lot faster, a lot easier, but a lot less dense. So typically, fibers grow along the length of the tree or the branch. So timber is one of the things that's anisotropic. So it's strong in one direction, very weak in the other direction. So what you'll have is basically, if you look at the image on the right hand side, material is very, very strong going along the grain, but then it's very, very weak when you're trying to, sorry, it's very, very strong when you're trying to cut across the grain, and it's very, very weak when you're trying to cut along the grain. Because that is how basically, if you ever see those videos or like people's demonstrations with like karate and stuff, that when they like headbutt boards or karate chop boards and they break, if they just took that piece of material and just flipped it 90 degrees, it would be a lot more difficult to actually break it. So with timber, you never just cut it down and you work with it. You've actually got to season it so it can be used. So when it's first done, it's green timber because it's still got a lot of moisture in it. Now you need to remove that moisture. So there's two main ways of doing it really. So you've got air seasoning, which is the traditional sort of way, pretty inexpensive, and all you are doing is just stacking the material up, and you put little like spaces in between them, so that air basically you stack them all up. You put them outside under like a little canopy or a little roof, and the air just circulates through all that timber and slowly takes the moisture out of it. Typically, you'll use this for timber that is going to be used for outdoor uses because it is basically keeping the same sort of moisture as the outside anyway, so it's going to withstand that atmosphere very, very well. Then you've got kiln seasoning, which is more expensive because you have to have the actual kiln and the equipment for it. But you have a lot more control, so it's a lot faster because you actually control the humidity and the actual temperature that you're seasoning things on. So planks are stacked the same sort of way that you would for air seasoning, but then you have the humidity actually controlled. So you'll start off with it being very, very steamy, and then slowly you make the temperature hotter and you make it dry so there's less moisture in the air, and you actually control the rate at which that moisture comes out of the timber. So the whole reason why you will season basically is because if you were to make something from timber that has not been seasoned, so it's still got a bit of moisture in it, it's going to act like something's going to happen to it. Like it might twist, it might warp, it might cut, or cracks might just appear. It can be quite expensive and quite damaging. If you ever buy like a nice piece of material and it's not quite dried out and you leave it and it ends up bowing, and it becomes useless really because it's not level. You can't mark out, you can't cut anything accurate with it. There's also the issue that if you do all your joints and everything and you construct something and then the moisture comes out of it afterwards, joints won't fit anymore because material has shrunk or it's twisted, so things don't line up anymore. So the other benefits of seasoning is that it makes it less susceptible to decay or rot because the moisture isn't actually in it. You have better strength and stability, and it makes it less corrosive to metals as well. So it depends basically. The whole reason why things will shrink or twist or bow or anything like that is just to do with humidity in the air compared to the moisture inside the material. The problem is with timber is it shrinks in all different directions depending on the material and the temperature it is. So some areas will shrink a lot more. So basically, so if you look at the diagram here, so the shrinks the least going across the rings here. So this is like you cut the tree in half. You got the rings there, so you can see how old the material is. It shrinks the greatest going along the growth rings, and it doesn't shrink very much going along the length of the whole piece of timber. The trick with seasoning really is to try and get it to dry equally so that it will all shrink at the same sort of rate. If everything shrinks at the same sort of rate, then you don't get your cuts, your cracks, or anything like that. Nothing bad happens. It's just because certain parts have shrunk and dried faster that it ends up pulling and twisting and those sorts of things. And then just so I've just talked a few different terms there. These are the sort of examples that I'm talking about. So things like splits, and then you've got things like cupping, bowing, and warping is basically where the material just it sort of dries in one side and not in the other, and it ends up actually curving the material. Um, you've also then got things like knots, which is essentially just where the branches are. So those are natural timbers. You do also have man-made boards. Now these are actually used quite a lot, and there's a huge advantage to these, um, because the problem you have with things like natural timbers is you're limited. The size of plank you can get is dependent on the size of the tree you've cut down. Now, obviously, you can join um, two bits of natural timber together. Absolutely, you can do. But one, it's an extra step, bit annoying. But two, it's a natural weakness because there's a join there now. So the benefit really of man-made is that you can buy sheets of MDF, ply, chipboard, any sort of size that you want. So really, if you're going to say make like an office table, your options are either to make it out of one solid piece of ply, one solid piece of MDF and veneer it, or make it out of 3 or 4 bits of oak and join them together. And that will be a natural weakness that eventually will break. So the other benefits, apart from the fact that you can get any sort of size and thickness, is they're very stable, so they're not affected by humidity at all. There's uniform strength because there's no knots in it. They are a lot less expensive, and you can just veneer them with a thin layer of natural wood anyway. So honestly, no one would really know. It will still look like a nice piece of oak, still like a nice piece of teak, but it's MDF or it's plywood underneath. So these are the manufactured boards that you need to know. These are the ones most people know. These ones: MDF, plywood, and chipboard. So MDF is used a lot in model making and indoor furniture. So it is literally just compressed wood fibres mixed with urea formaldehyde, and typically you would veneer it or you'd paint it. You have to do something to it because it's not got a grain on it. So chipboard is actually, instead of fibres, it's wood chips, again compressed with resin. Most commonly used in flat pack furniture or countertops, so anything like IKEA style. Then you got plywood. Now there are actually 4 different types of plywood. You got regular plywood, marine ply, aero ply, and flexible ply. So the way plywood works is you have got thin layers of wood glued at 90 degrees to each other, so the grain is always going in opposite directions, or 90 degrees of each other basically. So it's very, very, very strong, which is why it's used a lot in construction. It's always done in an odd number, so you always have, so the grain can be going left to right and then up and down and left to right. So you've always got odd numbers of it, and again, it makes it incredibly strong. And you can also get very, very flexible ply, which is perfect for things like bent furniture or in construction for like skate parks and those sorts of things. The only thing you can't do plywood is steam bend, really, because the glue tends to dissolve with steam. The exception is marine ply is very, very resistant to things like steam and moisture, so that's used quite a lot. So this isn't something you'd necessarily need to know for example. This is sort of an idea to show you generally where a lot of the world's hardwoods and softwoods come from. It all comes down to the climate and also how much space, as in actual physical land, the country has as well. So not something likely to come up in an exam, but just something to make sure you are aware of. So once you've got your tree cut down, you actually have to do something to it before you can actually have it into usable planks, and that is called conversion. Okay, so you actually have to convert the trunk of the tree into something. So there's a few different ways of doing that. So you've got quarter sawn. So what you do is originally you'll have one a massive table saw, and first of all you're just going to cut it into 4 quarters. So imagine you've got a circle into 4 quarters. That's the first step. Then what you'll do, so if you go in order across here, you're going to cut down and then you cut in from the side. And then you've got 2 planks. Then you do it again, you come down and in from the side. And then you've got another 2 planks. And you keep doing that and keep doing that until you reach the end. Now it does mean that the first cuts you do provide you with the biggest planks. Then as the more you cut through it, the smaller the planks get. But it's a very efficient way, a very good way of utilizing. Couldn't think of the word there. Utilizing the right amount of timbers. There's not a lot of wastage. Next, you've got plain sawn. So this is where you will cut straight down. You don't bother about quarter sawn. You'll cut the edges off, and then you'll just cut straight down, all the way down the whole length of it, and you get nice, good lengths of it. Again, same thing will happen as you go to the middle. You have slightly wider planks because the size of the circle. And then the last one is end grain sawn. Has some uses. It's not as efficient, or not. You're not utilizing as much of the material as say quarter sawn or end grain sawn. As plain sawn or quarter sawn. So end grain sawn is essentially you take, like, if you've got like a cucumber or salami, you sort of cut the ends off it like that. Okay, so now 6 questions on the screen. If you pause the video for me, have a go at answering them, and then I'll put the answers on the board. Okay, answers are there. Look through, see how you did. If you've got any questions, send me an email or message on Teams and I'll get back to you.